Alright, today we're going to learn about sum and product of roots of a quadratic equation. We have this result. If the quadratic equation ax squared plus bx plus c equals to 0 has roots alpha and beta, the sum of roots is equals to negative b over a, and the product of roots is equals to c over a, where a, b, and c are the coefficients of the quadratic equation. So for example, if alpha and beta are the roots of 3x squared minus 5x plus 6 equals to 0, then alpha plus beta is equals to negative. Okay, b is negative 5 over a, which is 3. So this gives me 5 over 3. And alpha times beta is equals to 6 over 3, which gives me a 2. So in this way, we have a relationship between the roots of the quadratic equation and the coefficients of the quadratic equation. Let's look at an example now. In the first example, if alpha and beta are the roots of 2x squared minus 4x minus 3 equals to 0, where alpha is bigger than beta, alright, this is the assumption we normally make. Find the values of alpha squared plus beta squared in A, and B, 1 over alpha plus 1 over beta, and in C, alpha minus beta. Okay, let's do each of them separately. So let's look at A first. Okay, I want to find alpha squared plus beta squared. But in any case, first we must find out the sum and product of the roots. So in this case, we know that alpha plus beta is equals to negative 4 over 2, which gives me 2. We also know alpha times beta is equals to negative 3 over 2. Okay, so how do I find alpha squared plus beta squared? So first we note that alpha plus beta squared is equals to alpha squared plus 2 alpha beta plus beta squared, right? So from here we know that alpha squared plus beta squared is equals to alpha plus beta squared minus 2 alpha beta. Alright, I just brought one of the terms over to the left hand side. Okay. So alpha plus beta is known, alpha times beta is also known from above. So we just do a substitution. So alpha plus beta is 2 squared minus 2 times of negative 3 over 2. So which gives me 7. Right, so far so good. So let's look at the second example now. Okay, for B, I want to find 1 over alpha plus 1 over beta. So in order to do so, the trick is to combine these two fractions into 1. Alright, so in the numerator we have beta plus alpha over alpha beta, which is the same as alpha plus beta over alpha beta. And we know the top and the bottom. So alpha plus beta is 2. Alpha times beta is negative 3 over 2. So we get negative 4 over 3. Or 1, or negative 1 and 1/3. Okay. Okay, let's move on to C. Alpha minus beta. Okay. So the approach for alpha minus beta is to first consider alpha minus beta squared. Okay, why? Let's take a look why. Okay, if I have alpha minus beta squared, I get, when I expand, I get alpha squared minus 2 alpha beta plus beta squared. Okay. Now, but the issue is, okay, actually no issue, right? Because we have already found alpha squared plus beta squared earlier, and we know what is alpha beta, right? So alpha squared plus beta squared in the earlier part is equals to 7 in A, and alpha times beta is equals to negative 3 over 2. So this gives me 10. Alright? So taking square roots on both sides, alpha minus beta is equals to root 10 or negative root 10. But bear in mind that alpha is bigger than beta, so the answer should be positive when I take the difference. So this is rejected, since alpha is bigger than beta. So the answer is square root 10. Let's move on to second example. Alright, this time round we're going to look at forming new equations from given equations with slightly different roots. Okay, so what do I mean? So if alpha and beta are roots of the equation 2x squared minus 5x minus 1 equals to 0, form equations whose roots are, okay, in A, 3 alpha and 3 beta, in B, alpha plus 1, beta plus 1, and in C, alpha over beta and beta over alpha. Okay, let's do each question separately. So in A, what I'm going to do is, okay, as usual, find out what is the sum and product of the roots of the original equation. So we know that alpha plus beta is equals to negative 5 over 2, so it gives me 5 over 2, and alpha times beta is equals to negative 1 over 2. Okay, we're going to make use of this in all three parts. So in the first one, we know that, okay, 3 alpha and 3 beta. Okay, so before we even start all this, let's make something clear first. Okay, because of our result here, okay, a corollary of this result, okay, is that the equation with roots alpha and beta should always take the form of x squared plus, minus alpha plus beta times x plus alpha times beta equals to 0. So how did this come from? Well, if alpha and beta are the roots, I should be able to write it in this way, right? And when I expand it out, this is what I'm going to get. So if I put the sum here and the product here, this equation will always have roots alpha and beta. So we're going to apply it here. Okay, so before we do that, we must first find out what is the sum of new roots. Okay, which is 3 alpha plus 3 beta in this case, because 3 alpha and 3 beta are the new roots of the new equation. So this is going to give me 3 alpha plus beta, which is 15 over 2. Similarly, for the product of new roots, this is 3 alpha times 3 beta, which is the same as 9 alpha beta. So this gives me negative 9 over 2. Hence, the new equation will take the form of x squared minus a sum, which is 15 over 2 x plus product, the new product, which is negative 9 over 2 equals to 0. Okay, don't forget, because this is the equation. So if I multiply both sides by 2, okay, I'll get it in a simpler form. Right, so this will be my final equation. And this equation here has roots 3 alpha and 3 beta. Okay, let's try to do this with the other part B. Okay, to strike all this off. the technique is the same. So sum of roots in this case, in part B, is alpha plus 1 plus beta plus 1. This gives me alpha plus beta plus 2, which is 5 over 2 plus 2, right? So that gives me 9 over 2. Okay. Product of roots, alpha plus 1 times beta plus 1. Alright, so this simplifies to alpha beta plus alpha plus beta plus 1. And we know, okay, the values of all these terms here. Alright, so I get alpha beta is negative half plus 5 over 2 plus 1. And that gives me 3. Hence the new equation will be x squared minus sum of the new roots, 9 over 2, plus the product of the new roots, which is 3, equals to 0. Again, I multiply both sides by 2, and I'll get this as my final equation. Okay, let's try out for the last one. Okay, in the last case, we have, okay, for C, we have alpha over beta and beta over alpha. So sum of new roots will be alpha over beta plus beta over alpha, which gives me alpha square plus beta square for alpha times beta. Just like in the earlier example, to get the numerator, I write it as alpha plus beta squared minus 2 alpha beta over alpha beta. So I just substitute what I know from the earlier line into this expression. So I'll get negative 29 over 2. For the product of new roots, it will be alpha over beta times beta over alpha, which just gives me 1. Right, that is straightforward. Hence, the new equation will be of the form x squared minus negative 29 over 2x plus 1 equals to 0. And then I simplify it, I'll get 2x squared plus 29x plus 2 equals to 0. So that's my final answer. We're going to end off this section with the last example that is slightly different from the rest. Now, if I know one of the roots of the equation, I could actually derive other equations that contain the root alpha, okay, or beta. So given that alpha is the root of this equation, okay, let's show some other varying equations with alpha inside as the variable. So in A, I have alpha cubed plus 2 alpha plus 3 equals to 0. And in B, I have alpha power of 4 plus 5 alpha squared plus 9 equals to 0. Okay, in this case here, right, since alpha is a root, okay, of this equation, obviously it satisfies alpha squared equals to alpha minus 3 by substitute inside. So how could I make use of this, okay, to help me form the new equation in A? Well, if I multiply both sides by alphas, I'll get alpha cubed equals to alpha squared minus 3 alpha. Now why do I want to do that? Because I have a alpha cubed and I want to make it appear. Okay, but I'm not done yet because there's no alpha square in the other two terms. But I know that alpha square is equals to alpha minus 3 from my earlier equation. So I just substitute alpha square by alpha minus 3. Minus 3 alpha. So this gives me negative 2 alpha minus 3. So if I bring everything to the left hand side, I get alpha cubed plus 2 alpha plus 3 equals to 0. So show. Okay. So the process is the same in the next example. Okay, in B, let's try to do B. Okay, in B I have a alpha to the power of 4. So in this equation, alpha squared equals to alpha minus 3. I multiply both sides by alpha to the power of 4. So okay, alpha to the power of 4 equals to alpha cubed minus 3 alpha squared. Okay, so that's one way to look at it, and you can. Okay, but remember, what was alpha cubed? Okay, in the earlier example, we know that alpha cubed is equals to negative 2 alpha minus 3 alpha squared. Okay. Now, however, in your equation, there is no alpha. There's only alpha squared. Okay, so we must make sure that we can change alpha into alpha squared. Okay, but how to do that? Again, in this equation, okay, we know that alpha is equals to alpha squared plus 3. Aha. So we make a substitution here. Okay, and then we expand everything out. I get minus 6 minus 3 minus 9. Okay, and bring everything to the left hand side. And this is my final answer which I wanted to show.